Welcome again to another Carpenter example tutorial, and here we have a plain electromagnetic wave with the 500 nanometer wavelength. This is incident at a polar and azimuthal angle, and the wave is plane polarized with the electric field vector that stands central to the surface of our goal substrate. And here we have some definitions for polarization, transverse electric, polarized electromagnetic wave, and also for incident, dielectric substrate, and electrostatic fields, also polar angles, azimuthal angles, angle of incidence. So these will be provided in a Word document, and I'll put the link in the description below for you to access. And now we have our global definition parameters, which are important. The expressions are extremely important. The first four are the sizes of our geometry, and the others are the azimuthal angle and the polar angles of incidence. We will get that from the study, and some others will be automatically computed as well when we run our study. And we have our definitions, local variables. So we can now go into COMSOL and get this done. Now we have COMSOL fully loaded and ready. Let's navigate to the model wizard. Let's go to 3D. Let's go to optics, wave optics, and let's go to electromagnetic waves, frequency domain. Let's click add, and we need to add 2 of these. And now let's go to study, and our study should be empty, and let's click done. Now let's go over to global definitions, parameters 1, and we are going to enter the values provided in the Word document. So let's go ahead and do that. 750 nanometers, square brackets. And let's put these in lowercase. And once you click outside, it automatically converts your value, and then you can simply type a description for each. So I'm going to pause the video and input all of my parameters, and you can just navigate through the Word document and copy and paste your parameters. Now our parameters has been set up, so I expanded these out so you can take a quick look. If you need to pause the video here, you can. Okay, so I'll go back to normal, and let's go over to home, our home tab. So make sure that we are in your home tab here, and let's go to import, and I will also provide this geometry for you. I'll put the link in the description below. So you need to go to browse, and then you will have to navigate to where you stored your geometry. So this is the geometry here, and I'll import it. And once done, I need to click import. Okay. Now we have our geometry imported. We need to draw our A and substrate. So let's navigate to geometry. So if you're at home, you go to geometry and we need to create two blocks. So let's click on block and we need to import the width plus 2 times the amount of our perfectly matched layer. So remember, we get our width from our parameters that we set up, and then the thickness of our perfectly matched layer as well, and the depth is the same, and the height will be A plus our perfectly matched layer. Okay, let's go to position and choose center, and the Z that's A plus the thickness of our perfectly matched layer divided by 2, and we need to go down to layers here, and of course our layers is our perfectly matched layer, the thickness of that. Now let's go to layer position, and we need left, right, we don't need bottom, we need top, and we need front and back, so everything except bottom. Okay, let's click outside here. Let's come to our model builder. Let's right click on block 1 and duplicate, and let's uncheck top and select bottom, and we need to make some changes here. Z should be minus, okay, and we also need to change the height. So the height needs to be changed, so that will be the height of our substrate rather than the height of air. Okay, so we have, let's get outside here. Yep, that's good. And for the Z position, yeah, we already changed it to minus, but it won't be air. That will be the height of our substrate. So it's minus height of our substrate plus the thickness of our perfectly matched layer divided by 2. And these are important, so we have to make sure they are correct. And the layer position should be left, right, back, front, and bottom. Okay, and let's click build all objects and see if it's correct. Let's click on zoom extents. Yeah, and this look correct. Let's navigate to transparency. Okay, and we can change, let's try wireframe rendering. Yeah, and we can select transparency again. And okay, so if we hold your mouse and push away from your body, then zoom in and come to your body, you zoom out. Yeah, that looks fine. Now we need to add some definitions, and let's go to the definitions toolbar and let's click explicit, and here we need to select domain 18, 19 and 25, But before we do that, let's give our explicit domain a name. So let's call that physical domains. And if you look at the previous video, I showed you how to set up selection lists. For those who haven't done that, you can go to Home, Window, and you have the option here, Selection List. So once you click that, you will see it pop up right here, and with that you have all of your domains and your boundaries here, depending on which one of the geometric entry level you have selected. Okay, so we need 18, we need 19, and we need 25, and then click this plus sign, we say add to selection, and here we select our first physical domain. Okay, so you can now go back to your model builder, and let's go back to definitions for those who came out of that part of the toolbar, and let's go to complement and select complement. And for complement, we need to make this perfectly matched layer domains, so you can give it that name. If you want to make it short, you can make it short, PML. And let's click this under selections here. So let's click this, and we have selections to invert, and let's select physical domains and click OK. And now let's go to our definitions and add another explicit, and this time we're going to make this one our nanoparticle, and we need a domain. So domain 25 is our nanoparticle. Yeah, and then click add. Beautiful. And we have our nanoparticle, so now we need a nanoparticle surface. So let's go to geometry definitions and explicit again, and here our nanoparticle surface, so we make sure we give it that name in the label, and then go to selection, and our surface will come from the same 25, add, and we need to make some changes here. So output entities, of course we need to change this, and we have to make this boundaries. Okay, also we need to go to definitions, and we need to go over and click perfectly matched layer. So that is right here. And now with that done, we need to go to the selection list, so right here, and where we not too long created our previous definitions, now they are here, so you can select perfectly match their domains, and we need to go down to scaling. So here we have scaling. We need to make some changes here. So from the list, scaling, so we need to go to physics here, and let's select electromagnetic waves, frequency domain 2. It is our second physics. Okay, and let's go over to our definitions again, and let's look at local variables, which is here. So let's select on that, and we now need to add some variables. So let's select from geometric entry level. Let's choose domain. Okay, and from this table, let's input these values. So this should make our expression 0. Okay, and now we need to add some material. Before we add any material, we change geometric entry level to domain. So let's change selection to perfectly match layer domains, and our expression. So let's enter 0. Okay, now let's build our air. Now there's two materials. There's material under global definition, and there's material under component 1. Okay, so the best practice is to close global definition, so therefore you won't make a mistake here. So now we right click on materials under component 1. So you have materials here. These definitions can be closed for now, so you can close these. You can close your geometry for now. And this material, this one, right click and select blank material. Okay, now I'm going to make this a little bit wider so we can have access to these. Okay, so here our material name should be air, and here let's make that NA, and also we actually define this in our parameters. Okay, and we need to create a substrate as well. So let's go ahead and do that. So let's go to materials, right click, blank material. So now we have material 2, and of course we need to label it, and we have a wide range of selection to do. This is where the selection list comes in very handy. So let's go 1 and 2, 5. Use control when you're selecting your new value. So 5, 6, 9, holding control. 10, 13, 14, 17, 18, 21, 22, 26, 27, 30, 31, 34, and 35. So add, and let me make this a bit wider. And this one we had N before, and B. Okay, that looks good. And let's go to home, and let's select add material, and we need to add some gold. So let's look for optical. So it's loading, and we need inorganic, my favorite word. And let's go to gold right here, and let's go to models and simulation. Let's make this a little bit wider for you to see. So let me make this a little bit wider. Good. And we need to select Brendel Bowman model. Okay. Yes, this one looks fine. And let's click add to study, or add, well, add to component, sorry. Okay, let's go back to our model, and here it is. If I click here, let me collapse this, so click back here, so that closes. Let me click here, then click back here, and we need to make some adjustment to this. So let me make this a bit wider, and from the geometric entry selection, we need to add our goal to the nanoparticle. Yeah. Okay. So we set up all our materials, and this seems fine thus far. Now we are ready to specify our physics. So let's start by setting up the first interface so that it computes the full wave solution to the plane wave falling in on the semi-infinite substrate. So how do we do this? Let's go to our model builder, and let's go down to our physics, electromagnetic wave. So firstly, let me adjust my pins. Right, so let me select electromagnetic wave frequency, which is our physics, and take a look at it. Now we have a domain selection, and here's all domain. I'm going to select physical domains. Okay, that looks good. So let me just adjust these pins a bit. Right, I can work with this, so you can also see. So the first one, we select our first domain, electromagnetic waves frequency domain, and change the domain selection, okay, from all domains to physical domains. Okay, so that's good. And now for the second one, well, let's sort this out. Okay, now let's go to physics. Let's go to physics, and let's select domains, and here let's choose wave equation electric. Okay. Now in the settings for this wave equation electric, okay, because we had one that automatically came in when we choose our physics, so we add this one. So let's go to our domain selection and let's choose nanoparticle. Okay, so let's go down to, let's scroll down here, and electric displacement field, and there is the refractive index real part. So the end part, let's select this and let's use user defined, and here there should be NA from our parametric variables that we set up. Okay, and for K, user defined as well. Okay, right. Okay, so this redefines the nanoparticles as air, so that seems fine. All right, now we need to define some variables for the mode field amplitudes to the ports, because we have two expressions. So let's go over to our model builder definitions. Let's right click on this and let's choose variables. Okay, so now I can just make my P in here a little bit bigger, and let's go down to geometric entry selection, or geometric entry level, and let's choose boundary, and let's go to our selection list and select 62 and 68. So scroll down, 62 and 68, and add, and go back to model builder, and now let's enter some equations. So minus sine times phi and cosine times phi. And this will be x and y. So that will be y. Okay. And now let's navigate to our physics toolbar. Well, we are already in our physics toolbar. If you're not inside of it, come here, right here. So click there. And let's go to boundaries, and we need to choose port. Okay. And we need boundary 68. So selection list, boundary 68, add. Okay. And now let's make some changes here. So for the port name, we can leave as is. For the port input power, we need to type some values from our parameters. So let's put P there, and type of port. What type of port do we need? Type of port. Let's make that periodic. Okay. And port mode settings. So for the port mode settings, we need to specify something here. So we had set up the X and the Y before. So this should be Y. So let's place those values there, and need to add the angle of incidence and the refractive index for the domain adjacent to the port. So let's scroll down a little bit. So we have evaluation angle of incidence. So there should be theta and phi. So theta and phi. Yeah. All right. Okay. Let's scroll down a bit more, see if there's anything else we need to do here. So we have automatic diffraction order calculation, and of course we already set up these in the parameters, so NB, and I want to double check. I want to go to variables 2 and double check something. Always go to double check. So let's go back up to our variables 2, and something didn't seems right there, so this is actually incorrect. So here we should have that, and here we should have Y, and X should be minus sine phi. So some reason the values went in correctly. Okay, so that seems better. So let's go back to port 1. Let's scroll down. Yeah, that looks better now. Okay, let's add another port. So domains. Well, not domains. We're in physics, boundaries, and port. And this time we need 62. And if you notice, when you select these, they actually show up in a graphic, so you have an idea exactly what you are selecting. Okay, so let's add 62. And let's choose periodic from what type? For our type of port. Okay. And we need to add some values here, just like before. No, Sorry, don't worry about that. Don't worry about that there. This will be Y. And this should be 0. Okay. And for the automatic diffraction or the calculations, this should be NB. Okay. So that seems correct. But we will know after we run our computation. Now let's go to our physics toolbar, boundaries, and we need to add a periodic condition right here. Okay, and we need 60, 63, 113, and 116. Scroll down, let's get 113. Use Control on the keyboard, and 116. And if you notice, if you select and you're not getting the opposite, left and right, then you know something is wrong. So add. That's what you wanted. And let's, for the type of periodicity, we will need to choose flocet. Okay, and for the K vector, let's choose from periodic port that we set up previously. Okay, now let's go to add a second periodic condition. Remember, we have two physics, we're doing two, so let's add another one. And this time 61, 64, 74, and 77. So 61, 64, 74, 77. Add. Okay. And flocet. A flocet. Let's choose that here. And from periodic port. Okay. And now let's go to our model builder, and you need to click on our second physics. So let's scroll down. I'm going to bring this out for you to see clearer. So all these were done in our first physics. Let me collapse definitions. Let me collapse material, close, not collapse, close. And I'm going to close our first physics. So we now have our second physics open. This alone should be open. Okay. And let's click on this second physics. And now let's make some adjustments here. So formulation, let's drop this down, formulation. Let's choose scattered field. And we'll enter our physics values. So this should be, so you can just change this to Y and change this to Z. Okay, and that should complete the settings for our physics. Okay, all seems good thus far. Now we need to define a mesh with a maximum mesh element size of 1/6 of the material wavelength. How do we do that? We need to add a free tetrahedral node, and we need to go to mesh to add that. And here it is. Okay. So now in the model builder, let's click on this and element size. Let's change this to what will work here. Okay, let's select customs. Our custom, so this is predefined. Okay, let's click custom. Maximum element size, let's change that. Okay, so we have the wavelength divided by 6. Okay, and let's now add a size node for the nanoparticle. So let's right click on mesh 1, and let's go to size. So you can right click on size 1 and move up. So you have size 1, and you have the free tetrahedral below that. Okay, that's just to make it orderly. Now with size 1 selected, let's change the geometric entry level and change that to domain, and let's choose our nanoparticle. So we know that by now it should be 25. Add model. Okay, and change this to custom, as we can add our own, and we need to select the maximum element box, and we want about 43 nanometers. So maximum element size, and 43 nanometers. Okay, that should be fine. Let's duplicate this, size 1. And let's locate the, that we need to change here. Let's clear this. So here, clear. Make sure you select size 2 before you hit this clear, okay? And let's go to our selection list and select 18 and add model builder. And let's make this our wavelength for the maximum element size. Our wavelength divided by 6 divided by our refractive index substrate, which is NB. Okay, now we need to add a triangular mesh for 2 of the periodic boundary condition boundaries, and then use copy mesh. Okay, so this will make the boundaries identical. How do we do that? So we are in mesh toolbar already. Let's navigate to boundary and click free triangular. Okay, let's go to selection list and let's select 60, 61, 63 and 64. So 60, 61, 63 and 64. Add, back to our model. Now in the mesh toolbar you should have copy and you select copy face. Okay, and for copy face, let's go to selection box or selection list and select 60 and 63 and click add. Okay, so let's go to our destination boundaries. Let's turn this on and we want the opposite side. So what is the opposite side? It's just as the previous 113 and 116. I'm sure that you should remember that you selected this before. 113, 116. Add. Okay. Now let's right click on this and duplicate. Okay. And let's clear. Let's select this one. Let's clear. Let's select this one. Let's clear. Let's go back to this one. Let's start here from the top. And let's go to our selection list and select 61, 64, and click add. Let's come back here. Let's go to list and 74 and 77, 74, 77, add. Okay. Now for our free tetrahedral, so we need to click our free tetrahedral. That's free triangle or free tetrahedral, and let's make some changes here. We have remaining for our geometry level, nope, domain, and we need to select our domains 18, 19, and 25. 18, 19, 25. Add. Okay. So in our mesh toolbar, select sweep. And let's move down, sweep below our free tetrahedral. So right click and say move down. So we are working orderly. Now let's right click and sweep one and select distribution. And for the number of elements here, let's type 8. And let's build all. You can do it from here or you can do it from here. Well, let's do it from here. Okay, let's go home. You can do it here, you can do it in your mesh, but I'll do it from here. Okay, and our mesh is completed. Now before we solve our model, let's set up some components, couplings, and variables. This will give us the cross section across our substrate. So let's navigate to definitions. If you are home or anywhere else, come to definitions right here, and let's go to non-local couplings, integration, and let's give it a name, but not for the labels, for the operator name. Let's give it that name, and for the selection, let's choose nanoparticle, and we're going to create another one of these, and this one will be the nanoparticle surface. So for the operator name, let's give it that, and let's change this to boundary, and we have the nanoparticle surface right here. Okay, and now we need to add some variables. So let's go to local variables, and we're going to add some variables here. So these are also inside of the Word document, which I've provided. So if you go to the description below, you will have the option or the link to download the Word document. Okay, so I'll pause the video here, and you can go ahead and get these from the Word document. Okay, now I've finished putting in my variables, and here they are. I expanded the pane, the settings pane, so that you can see clearly. And with this done, we can go and set up our study. Okay, now let's go to our model builder. Let's close some of these. Component 1, you can just close that, and let's go to our study 1. And let's clear generate default plots. Okay, and let's go to study toolbar. If you are not in the study toolbar, it's home, then study toolbar, and let's click on parametric sweep. Okay, and let's enter some values in our table. So let's add these values. So how do we do that? Come down here and you click add, and let's locate this one, theta polar angle of incidence. Do we have that here? Yeah. Okay, this should be in air. Okay, that should be in air. And this is a good demonstration that you can just simply go back to your global definitions, parameters, and you can just come here and just say add A to the description. Okay, and if you go back to your study, parametric sweep, it should come up here in here. So now you have an idea exactly what the parameters holds. Okay, and let's enter the setup values. So you can go ahead and enter these. And also let's add some more. And this time let's go to this one, the azimuthal angle. And let's add some more values. Oh. Okay, great. Now in the study toolbar, let's click study setup. And let's select frequency domain, wavelength domain. So frequency domain and wavelength domain. Okay, and we need to add for the wavelengths. Let's add something from our parametric setup, our parameters, global parameters, and let's clear. We need to remember we have two physics, so we need to clear one. So because this is the first one, we need to clear the second one, so you have to be careful. So electromagnetic waves frequency domain 2, this is the one that we need to clear. Okay, and now let's go to study again, and we need to add another study set, and we need to add basically the same thing. Frequency domain wavelength. Okay, and gonna give the wavelength the same parameters, and this time we need to clear the first one. Okay, you have to be very careful when you're setting up your study. Let me close this box that I had open on the right hand side, and let's just double check our study a little bit. So wavelength domain, and we set up our wavelength. So we give wavelength from our parameters tables, because we already have wavelength here, right here. So we go back to study, we put that parameter right here, and we clear the second one, then we create another domain, and we clear the first one, and we apply our parameters for the wavelength. That looks good. So let us go ahead now and run our computation. Okay, so how do we do that? You can click compute here or here, your choice. Let's go. This will take a while, so enjoy your break. See you when this completes. Okay, our computation is completed. Now let's collapse study. Let's collapse, well, not collapse, close study and global definitions if you have them open. Always good to keep your model builder neat. And let's focus on our results. So let's expand data sets in results. Let's click study solution 1, and let's call this substrate. Okay, and let's go to our study toolbar selection. For selection, we want to select a boundary, and let's add 61 and 87, 65 and 87. Use Control to select both. Click Add. Go back to your model builder, and let's right click. Let's close this. Let's right click on substrate and duplicate. Okay. So this one, let's call this one particle. Okay. And what I'll do, I right click here and then move it up after I renamed it. And let's change the firstly, before we do anything else, let's expand this. Let's click selection and let's select nanoparticle surface. Okay, and for the study 1 parametric solutions, so let's close particle. We're finished with that. Let's select study 1 parametric solutions. Let's go to our results toolbar, attributes, selection, and geometric entity selection. Let's choose domain, and from here, this selection list, let's choose physical domains. Okay. Now let's go to our results toolbar and let's click on 3D plot group. You can close this. Once you're finished with something, you can close it. So we're now going to set up our 3D plot group. Let's give it a name. Let's call this background field Y. And let's choose from here, let's choose study 1 parametric solutions. Okay. And let's right click on background field Y in our model builder and select slice. And here in the settings for slice, let's click replace expression, and let's go to electromagnetic waves and the component 1, frequency domain, so this one, let's go to electric, and let's go down and select one of these. Which one would work best for us? I think we should go to the electric field and select electric field Y component. Click on it twice. Great. And we need to now go to the plane data, and for planes, let's enter 3. Okay, and then once that is finished, you can hit plot here or here, and we generated our first plot. Okay, now for background field Y in the model builder, let's click on that. And from the parameter value here, parameter value theta phi, let's choose 3. Okay, and let's plot. Now let's right click on the background field, surface. Okay, and let's go to our data sets, and let's choose substrate, solution 1, and let's go to expression here, and let's type 1. Okay, and let's go to our title, expand our title, and title type, let's choose none. Okay, and coloring and style, from the coloring choose uniform. Okay, and for color, let's choose gray. You can choose any color that you want. Let us rotate this a little bit, and what I'm going to do, I'm going to hit plot, and as you can see, we created our surface. Now let's duplicate. So let's firstly close these, so we could duplicate our, right click and duplicate our background field Y. And let's just simply call it field, the one that we duplicate. Let's simply call it field. Okay, and let's collapse this. For slice, let's change the expression. So component 1, electromagnetic wave frequency domain, electric, and let's choose norm. Let's try the electric field, not this one, this one. Double click on this one, and let's click plot. And if we use the left mouse button and rotate and examine the plot, but we are not completed as yet. Now we need to add some global evaluation. So what I'll do, I'll zoom to extents and I'll go to default view, right? And let's minimize that. It's a good practice to save. And let's go to our results toolbar and let's go to global evaluation. It's a little bit difficult to find at times, so let's click on that. And let's, for the data sets, just here, let's choose study 1 parametric solutions 1 sol 2. Okay, and inside of the table, our expression is that, and let's evaluate. And here is our results. Okay, and you can examine those after. Now let's go to our model builder. Let's right click on background field Y. Let's duplicate that again and let's call it total field Y. So just replace background with total. And let's change expression. So therefore we have to collapse the total field Y. Let's take off the 1. Much better. Look outside. Right, much better. So we need to make some adjustments. So let's click on slice in total field Y and let's change the expression. So component 1, we need to this time go to electromagnetic waves frequency domain 2 and electric field, and this time let's select the field Y component and remember to double click. Okay, and let's go to our surface and for the surface okay, let's not interfere with the surface, leave that as is, but we will right click on total field Y and let's create a new surface. Okay, and for the surface, for the data sets, let's choose particle sol 1, and for the expression, let's type 1. For the title, none. Coloring table, uniform, and the color, let's choose yellow as we want to represent gold. And of course we have to plot. So if we use our left mouse button, hold it down and rotate, you can see we generate our nanoparticle in our results. Okay. Now let's right click on, let's close this. Let's right click on total field Y, duplicate, and let's call this total field norm. And let's expand this, slice 1. We're going to make some adjustments here again, and of course this is our second physics, our second solution that we want to make these adjustment to or for. So we need to select electric and electric field norm, this one. To double click on that, and let's click plot. Now let's create another global evaluation. So let's go to results, global evaluation, and let's enter these values, and let's click evaluate. Okay, and also let's enter some more expressions. And click evaluate again. And each time you can see we're generating results in our table. And let's add another expression. And let's evaluate again. Okay. Now let's do some power loss plots. So let's right click on total. Let's close this, then right click, duplicate, and let's rename this to power loss. So let's expand this. Let's select slice 1, and of course in our expression we need to change this. So frequency domain 2, let's expand that, and let's go to heating and loss, heating and losses, and let's choose total power dissipation density. Okay, double click on this one, and for the plane data here, for it from the list. Okay, leave it as quick. For plane, let's choose X and Y planes. For the entry mode, let's choose coordinates. And for the Z, let's input 50 nanometers in square brackets. Okay. And let's click plot. Now, this doesn't look too correct, so what we'll do, we'll go to surface, right click, and disable. Now we have our power loss that displays nicely, so you can go ahead and examine these. So let's close this. Let's go to default view, zoom to extents, and let's just go through our results. So we have our background field Y. Let's do the same, and you can always use your right mouse button and examine. Okay, and we have our field. We have total field Y, total field norm, and our power loss. Now let's go back to global evaluation tool. We need a table. For this, we are getting one values because it's only substrate. The reason why, we need to go to our data set and select study parametric solution 1. Okay, and let's evaluate this, and let's overwrite. It's okay, and now we have the table that we actually need. What you can learn from this is that you can always interchange your results. In other words, you can try many different things within your results. So your data sets, you can actually select and evaluate to generate the table that you need. Okay, so you can simply go ahead and examine all your results and see what type of data you gain. And that's it for this tutorial. Thank you for watching. Bye for now.